Welcome to the fundamentals of microphones. At the end of today's presentation, you should understand different types of microphones, how each different type works, and the acoustic properties of microphones. A microphone is a transducer. So what's a transducer? A transducer changes one form of energy into another form. A microphone changes acoustic energy into electrical energy. Microphones come in four basic types: dynamic microphones, capacitor microphones, then you got your crystal or ceramic microphones, and finally, carbon microphones. We care most about dynamic microphones and capacitor microphones. So let's see how these guys work. Every microphone has a diaphragm. It's this diaphragm that moves in proportion with the amplitude and frequency of the sound wave. It's the movement of this diaphragm that generates the electrical signal which represents the sound wave. The dynamic type of microphone relies on the principle of electromagnetic induction. Discovered in 1831 by Michael Faraday, electromagnetic induction says that a changing magnetic field will induce or cause an electric current to flow in a nearby wire. Faraday based his discoveries on work that was done by André Maria Ampère. Ampère demonstrated that an electric current flowing through a wire will create a magnetic field around that wire. This same principle works in reverse for electromagnetic induction. That is, if we start with a magnetic field from a permanent magnet and pass a wire through that magnetic field, an electric current will flow through that wire until the wire stops moving through the magnetic field. If we reverse the direction of the wire, current will continue to flow, but this time in the opposite direction. It is this electromagnetic induction which allows dynamic microphones to work. Technically, we have two types of dynamic microphones: the moving coil microphone and the ribbon microphone. Moving coil microphones are made by connecting a mylar diaphragm to a movable voice coil made up of finely wrapped wire. The voice coil is then suspended in a very intense magnetic field. Here's an illustration that shows how this moving coil works. Here we see a strong permanent magnet, a voice coil made up of finely wrapped wire, and a mylar diaphragm. The force of the incoming sound waves push against the diaphragm, which is connected to the voice coil, causing this voice coil to move through this strong magnetic field. By this coil of wire moving through this magnetic field, a small electric signal is generated. That is, the magnetic field induces a current into our voice coil. The second type of dynamic microphone is a ribbon microphone. Though it relies on electromagnetic induction, a ribbon microphone is seldom called a dynamic microphone. It is usually called a ribbon microphone or a velocity microphone. Instead of a voice coil, a ribbon microphone uses a thin corrugated aluminum foil ribbon. A ribbon microphone is much less rugged than a moving coil microphone. In this diagram, instead of a moving coil, we see a flat aluminum ribbon suspended in our magnetic field. This ribbon serves as the diaphragm of the microphone. So the changing pressure of the sound waves causes the ribbon to move in the magnetic field, and a small electric current is induced or produced as a result. Courtesy of Professor Stan Coutant, here's a beautiful picture of a classic RCA 44BX ribbon microphone. Removing the perforated windscreen, we see a very hefty permanent magnet and a very thin corrugated aluminum ribbon. This concludes Module 5A, but before we continue, can you describe the operating principles of a dynamic microphone? If you can, then let's go ahead to Module 5B and we'll take a look at the operating principles of a capacitor microphone.